Hello, in this video I'm going to show you how to solve the definite integral from 0 to 1 of the square root of 1 minus x squared dx. We're going to do this by u substitution. We let our x be equal to the sine of u, so that dx will be equal to cosine of u du. Now at x is equal to 0, our u will also be equal to 0, since sine of 0 is equal to 0, and at x is equal to 1, our u will be equal to pi over 2, since sine of pi over 2 is equal to 1. So our integral becomes I is equal to the definite integral from 0 to pi over 2 of the square root of 1 minus sine squared of u times cosine of u du. Now the expression inside the square root is equal to cosine squared of u, according to one of the fundamental relations in trigonometry. Now the square root of cosine squared of u will be equal to the absolute value of cosine of u, but since in the interval from 0 to pi over 2 cosine of u is strictly positive, we're left with just cosine of u. And cosine of u times cosine of u is equal to cosine squared of u, and our integral then becomes the definite integral from 0 to pi over 2 of cosine squared of u du. Now let's notice the double angle identity for cosine. Cosine of 2u is equal to 2 times cosine squared of u minus 1. This then implies that cosine squared of u can be expressed as 1/2 times cosine of 2u plus 1, which then implies that our integral I is equal to 1/2 times the definite integral from 0 to pi over 2 of cosine of 2u plus 1 du, which is equal to 1/2 times 1/2 sine of 2u plus u evaluated from 0 to pi over 2. Now sine at pi is equal to 0 and sine at 0 is equal to 0, so we're left with just the u part, so our integral I is equal to 1/2 times pi over 2, which is equal to pi over 4. This here is our final result, so our integral I is equal to pi over 4.